So only in this situation, in other words, when we're talking about a PC that fulfills all those characteristics, uh, is this letter combination true. So D equals P equals AR equals MR. Now recall, D equals P equals AR is actually always the case for any market structure, but then that's not going to necessarily be equal to marginal revenue unless it's a PC. So make sure you understand that too. So again, we can look at maximizing profits by looking at the total revenue curves, or we can look at it by looking at another route that we'll more frequently use. But first of all, let's look at total revenue. Total revenue curve for a PC is linear coming out of the origin. Obviously, if you sell zero, you're going to have zero total revenues. At $10, if you sell 10 of them, then you're going to earn $100. And again, since this is a representative firm, let's suppose that there's 1,000 firms in this industry, and we're talking about one of those 1,000. So they have 1/1,000th of the overall market. So that makes it easy to use these same numbers. So if we scale up, multiply by 1,000, that's the market. If we're not multiplying by 1,000, that's a particular firm in a PC. So that's the way we're handling it. So this is the representative firm if we don't have the extra zeros added here. And so on and so forth. So the total revenue curve is linear, and it's coming out of the origin. Now, another thing, let me go ahead and jump into it. I'll probably reiterate this later. But if you took the slope of the total revenue curve, that would be the change in total revenue divided by the change in the quantity. Guess what? That's exactly the same formula for our marginal revenue. So the slope of the total revenue curve is equal to the value of the marginal revenue at in any range. Now, these are the total cost curves. So we've got fixed costs. Notice again, we're in the short run. So fixed cost is flat. It's not changing. It doesn't change with the level of production and sales. Variable cost has this typical kind of sideways, lazy, backwards S, if you will. And then that drives the shape of the total cost curve. Variable cost plus fixed cost at any point would be equal to the total cost. Okay, now we superimpose the total revenue curve in with the total cost curve, and we've got some important points to look at. One is this point where they intersect. That would be the point where total revenue equals total cost. No, that's not profit maximization or loss minimization. That's actually what we call break even. So this is the break even point. Total revenue equals total cost. But then remember I said total revenue, the slope of that is marginal revenue, and I'll go ahead and tell you the slope of the total cost would be marginal cost. So marginal revenue, marginal cost. So where these two lines, curves, if you will, this is not a line, but the two curves are have the greatest gap, somewhere roughly in this region here, greatest distance. That would be profit maximization. In other words, the distance between the total revenue line and the total cost curve at vertical distance would be profits. Notice here the total cost is above the total revenue. This would be losses. So make sure you understand how to read it. Now back to the slopes. It may be a little hard to see, but at the point where there's the greatest gap, if you were to draw a tangent line here on the total cost curve, it would be exactly the same as the total revenue curve in terms of the slope. So what's the slopes of these? Marginal revenue, marginal cost. So talked about break even and talked about thinking about the spread between total revenue and total cost. But then we can also, as we've already gone through, think about marginal revenue and marginal cost and arrive at profit maximization. Now from here on out, that's what we will use. So we're looking at the point where marginal revenue equals marginal cost. Well, that's where they intersect. And so according to the cost structure of this firm, this typical representative firm, marginal revenue equals marginal cost would be a 180. So profits are maximized at a quantity of 180, given that the firm is in a PC market and the current price is $10 and the firm sees this cost structure in the short run. That's profit maximization as calculated by looking at the graph. You're going to need to do this. All right. Now, let's look at the fact that total cost, we could get at it by looking at the average total cost times the quantity. Because remember, total cost divided by the quantity would be average total cost. Now, notice I'm not saying change in the two. That would be marginal cost. Just saying the actual amount of total cost divided by the actual quantity at a particular point would give us average total cost. So we can go backwards. Instead of taking TC divided by Q quantity, we could take ATC and multiply by Q and we get TC. And the same for total revenue. So again, we can think about calculating total revenue by multiplying the price times the quantity. So total revenue would be the rectangle formed under $10 and bounded by 180. And total cost, we can get at that as well. So total cost would be quantity times average total cost times the quantity again. So that probably didn't make a lot of sense. So at any particular point, to get to the total cost at that particular point, we could take the quantity at that point at 180, multiply by average total cost at that particular point, which looks like, in this case, if I can visually go over, which is a little hard for me to see to do that, looks like it's maybe a tad less than $8. Somewhere in that range, close to $8. So whatever the average total cost is at that quantity, let's just say it's $8. That's the way you would find average total cost. Multiply average total cost times the quantity at that level, and that would give us total cost. So here's total revenue, what I talked about earlier. Here would be total cost. We're saying it's almost $8, not quite. Okay. And so what would be the difference between total revenue and total cost? Well, that would be profits. That could be positive or negative. So again, you're going to need to be able to do all these calculations based on looking at a graph and coming up with particular points, like where marginal revenue equals marginal cost. All right, so let's suppose that the market equilibrium price is now $8. For whatever reason, there's been a supply, there's been a decrease in supply for the entire market. Maybe some of the farms got out for whatever reason. Maybe there's weather conditions, or who knows. Or there's been a decrease in demand, and I said that I think wrong on the supply. It would actually be an increase in supply or a decrease in demand, and so that brings the market price down to $8. So at that level, let's see what would be happening at that roughly $8. Roughly, total revenue and total cost would be the same. Now, what would happen if the market price continues to drop to $7.50? Well, in that region, total revenue equals, marginal revenue equals marginal cost would be somewhere in this range right here, maybe close to 165, 170. But in that range, total cost would be greater than total revenue, but the firm is still covering their overhead. How do we know that? As long as the price that they're getting for the good is greater than the average total cost, which it is. Average total cost would be right off this lower curve, and the price is higher than that. So at least they're covering some of their overhead. See, if the firm were to shut down, they'd have to still pay their overhead until they can get out of the contract for their building or whatever those fixed costs are. And so it actually would behoove the firm, even though they're having economic losses, to stay in business because of the fact that they are at least paying down a little of their overhead. This is in the short run. Now, on the other hand, if the price falls below that point of average variable cost equals marginal cost, then total revenue is going to be so low related to total cost that the firm is not even covering their overhead, much less their variable cost. And so it'd actually be cheaper for the firm to shut down. So at the point where average variable cost equals marginal cost, that's called the shutdown point.